In lesson 7.3, we're going to be talking about sampling, predictions, and simulations. Probably one of the biggest statistical boo-boos in America was when the Literary Digest did a survey of 10 million Americans trying to predict the election of Landon and Roosevelt. When they did their survey, they chose names from the telephone directory and from a list of automobile owners. So they were choosing people of an upper income level in their survey, forgetting about the lower income level and the middle class people. And so the lower income and middle class were very fond of Roosevelt. So when the election came, everyone was totally in awe of the fact that the Literary Digest could have been so wrong. And it was all based on an error in the way they conducted their survey, a sampling error. In inferential statistics, we're making predictions from samples, like the Literary Digest took a sample and made a prediction that Landon would be the president. A sample is a collection of people or objects chosen to represent a larger collection of people or objects. So in the Literary Digest, their sample was of an upper income bracket of Americans. The population of that would have been the Americans living in the United States, or all the people in the United States would be the population. It's the entire group that is being used. Now, when you work with young children in the activities that I spoke to you about in lesson 7.2, you are using your classroom as a population. So getting a sample, or getting the concept of sample and population across to young children, is difficult because of the way we have to go about collecting data for them to work with. So when you have them jump across the creek, then the population is everyone in that class. And so getting a sample will be challenging for you in getting that idea across to them. The term random sample is every element in the population has the same chance of being selected. So if you use a hat and you put paper in the hat, then every piece of paper has to be the same size. It has to be folded the same way so that every piece of paper would have the same opportunity of being drawn. And that is a random sample. The process of getting a random sample is called random sampling. And so putting the objects into the hat and drawing out, it would be called random sampling. One way that we can do random sampling is by using a random number table. Now you have one in your book at the bottom of page 493 that you will be able to use. But there are many different random number tables, not just, this isn't the only one. There are many different numbers that are just randomly written down computer generated, calculator generated, that will allow you to get random numbers. The way that we can use a calculator to generate random numbers is to go on this is a TI-83 Plus. I go into Math. Well, first I have to turn it on. That helps. And then I go into Math, and then I have the options to go right to Number. And then I'm going to go down to actually I'm going to go right to Probability. So I'm going to Math, going right to Probability, and then I'm going down to number 5, which is Random Integer. That's the one that I use. And then you tell the calculator what random numbers you want to draw. So if you have 25 students in your class, you can do 1, 25. So I'm drawing the numbers from 1 to 25. Now, if you are choosing someone to be first in line, and every student has a number from 1 to 25, when you press enter, it is student number 8 that gets to be first in line. And then student number 15 would get to be next, and student number 7 would get to be next, and so on. So this is how you can use a random generator on a calculator. Now, the way you're going to use the random number table is if you are looking to choose 10 questions and you've got 50 questions in your population. So there's 50 questions I could choose from, but I'm only going to give you 10 questions on your exam. Which of those 50 will I choose? Well, I have a random number table here, and I'm going to hold it close as I can to, I don't think you're going to be able to see that well enough. Look in your textbook on page 493, and since I am looking for a 2-digit number, 10, when I choose digits that are acceptable, I have to choose 2-digit all the way. Like 1 has to be 01, 2 has to be 02, 3 would be 03, on down to 10. So, as I look at the numbers in the textbook, and I'm going to start with the first number and I'm going to read it going right. You don't have to read it going right. You can read it going down the columns. So there is no rule about how you read your table, but I will give you a rule when we take an exam because we would all have to do the same thing. But in doing a random survey, you can go right across the table or you can go down the columns. You can choose to use the middle 2, you can choose to use the right 2, the left 2, whatever you want to do. But as I read across, number 40 would be the first question that I would use on the exam. Going right, the next question would be 9. Going right, the next question would be 18. Going right, the next question would be 94. Well, there is no 94. We only have numbers up to 50. So I skip 94 and I go to 6. Then 62, we don't have a 62 or an 89 or a 97, and so now I go to 10. Then 2, I don't have a 58 or a 63, and I've already used 2. I don't have a 91, so I go to 44. So you skip numbers that you've already chosen, and you skip numbers that are not part of the population. So at 44, I skip 79, I choose 3, I skip 55, I choose 47, and skip 69, and I choose 14. And so now I have the 10 questions that would be on your exam from the 50 that were possible. In the next example, it asks that we choose 65 questions from 650 possible questions on the list. So now I have to go down 3 digits at a time. So 1 would be 001, 2 would be 002, and so on. This random number table is divided into 2s, but I now will be challenged to group them by 3s. If it's helpful to you, you can go down the column. So let's do that. Let's go down. So the first one I would choose would be 400, then 331, then 694. We'll have to skip that one because we only have 650. So 174 and 431. Now I have options. I can do the same thing with that second group, taking the first 3 numbers and going down in all columns. Then if I don't have enough numbers, I can come back and maybe use the last 3 numbers in each column. And then if I still don't have enough, I can use the middle 3 numbers in each column. I could go right. I could use 400, then the next 3, 918, then the next 3, 940, then the next 3, 662, then the next 3, 899, and so on. So in using the random number table, if you do not have directions otherwise, you have freedom to go right, up or down, whatever. Start wherever you want to and move however you choose. But you need to choose a pattern and then move in that pattern. But if from the sample it is a 3-digit sample, then you will choose your numbers in groups of 3. Now, there are ways of sampling that you can choose from, and one way of sampling is called a stratified sample. And this is where you take the population. Let's say the population is the Morgan County Elementary School. That is our population. I'm going to divide that school into groups. I've got a kindergarten group, I've got a first grade group, a second grade, a third grade, and a fourth grade. Then from each group, I'm going to choose according to the proportion that group is of the total. So let me kind of draw that out a bit. I've got a dead pin there. I've got the kindergarten class that has 100 students. I've got the first grade class that has 125 students. I have the second grade class that has 90 students. The third grade class that has 105 students. And the fourth grade class has 80 students. I won't choose the same number from each group. I won't choose 5 kindergarten, 5 first grade, 5 second. I will choose the number according to what part they are of the total population. So I have, let's see, let me get the total. I have 500 students in school. One-fifth of the students surveyed will come from the kindergarten class. $125 over 500 is 1/4. So 1/4 of the students chosen will come from first grade. 1/5 from kindergarten, 1/4 from first grade. $90 over 500 means that 9/50ths will come from the second. 105 over 500 and 80 over 500 is the proportion of students that will be chosen from each grade. Now, let's say that I want to choose 50 students in my survey. 1/5 of 50 means that 10 of them, I will choose 10 kindergarten students. 1/4 of 50 would be 12.5, so I'll probably choose 13 first graders. And then 9/50ths of 50 means that I will choose 9 second graders, and so on. Now, how I go about choosing these 10 would have to be a random sample. So I would give every kindergartner a number, and I would choose from the random number table the first 10. Or I would use a random number generator on the calculator. So once you decide how many will be chosen from each category, then those are chosen randomly. That's called stratified sampling. When we illustrate data in a bar graph or a histogram, sometimes the data, the bars, are lopsided. And we use the term skewed to represent data that's heavy on one end. It can be skewed to the right, can be skewed to the left. I remember which way that it is skewed because the thin side, or the tail, is the direction that it is skewed. So if it's heavy on the left, we say that it's skewed right because the thinning part goes right. And if it's skewed left, it's heavy on the right and it thins out going left. And so that's helpful to me in determining whether it is skewed right or left. In this example in your book on page 495, this one is skewed right. The tail goes right. And the one on the bottom is skewed left. The tail goes to the left. If the data is symmetric, then it's equidistant from the center with the same frequency. So if the left has one bar or one, then the right has one from the center. And it gradually goes up until the center is where most of the data falls toward the center. A very good example on page 496 of skewed and symmetric. And I'm not going to be able to get the book in there to show you. So you need to look on 496. You have a skewed right, skewed left, and then you have the symmetric. I also want you to look at the historical highlight on page 499. I think that's very interesting. We find that when we graph data onto a histogram, that most things that we graph that deal with nature or human measurements graph as a normal curve. Normal meaning symmetric. And that's why we call it a normal curve, is because it is very common in nature. This is what a normal curve looks like. If you make a bar graph, and the bars look like this, actually a histogram, sorry, you have an indication that you have a normal curve. So by plotting a histogram, you can judge how the data would look. We typically draw it as a smooth curve like this, the normal distribution. And the center of this normal distribution is where the mean is. If I have data values that are one standard deviation to the right and left, we write it like this. This is 1 standard deviation to the right of the mean, 1 standard deviation to the left of the mean. That's where you can expect to find 68% of the data. If you are 2 standard deviations from the mean, right or left, that's where you can expect to find 95% of the data. If you are 3 standard deviations to the right or to the left of the mean, that's where you can expect to find 99.7% of the data. So if you take a data value and you calculate the number of standard deviations you are from the mean, that is another way of judging whether you have an outlier or not. If you are above 2 standard deviations from the mean, if you're up here, if the data value is up here, then that is unusual. If it's down here, then it would be unusually low, and that would be considered an outlier. If we want to compare a student to an entire population, we can do that by using percentile. If a student scores in the 80th percentile, that means that they have 80% of the people scoring below them. We use that terminology often in standardized testing, end of course testing. So that if I'm looking at the bell curve and I am at the 90th percentile, that means that 90% of the people are below me. Only 10% of the people scored above me. And so that is how we use percentile. In dealing with the box and whisker plot, we talked about quartiles, and remember that's where we take our data and we divide it so that a fourth of it is below, a fourth of it between quartile 1 and the median, a fourth of it between the median and quartile 3, and a fourth of it above quartile 3. So you've got below quartile 1, between, and above quartile 3. So we've already talked about percentile in terms of quartiles. 25% below, 50% is below the median, 75% is below quartile 3, and then 100% is below the max. The z-score computes the number of standard deviations away from the mean. So we've already looked at the normal curve, and we've already talked about being above 2 standard deviations let me show you one more thing about that. We said that if you are 2 standard deviations below or above, what is between here is 95% of the data, which leaves 5% of the data to be shared equally in these two tails. So 5% of the data is shared equally. So this would be 2.5% of the population might be above, and 2.5% of the population might be below. So the 5% has to be split between the two tails. So only 2.5% of the population could be above, and that would be rare. 2.5% below, and that would be rare. So we say that it is a rare event to be more than 2 standard deviations away from the mean, either right or left. So we consider that to be a rare event. So let's look at what it would look like to calculate a z-score. The formula that we use is z is equal to the x value that you are given minus the mean divided by the standard deviation. So if you scored an 80 on a test, and the mean on that test was 75, and the standard deviation was 2 3/10. So you have to know that. You have to know what your score was, what the mean was, and what the standard deviation is. And we learned in lesson 2 how to calculate the standard deviation. So if I take everyone's test score and I find the average and I find the standard deviation, and I'm using the population standard deviation because if I give a test, you would be the population. So I would be able to find the population standard deviation. I can calculate the z-score by taking 80 minus 75 and dividing it by 2 3/10. and the z-score is 2 17/100 if I round it to the nearest hundredth. This is unusual. It's a z-score greater than 2, therefore it would be a rare event. The x value minus the mean divided by the standard deviation. Any z-score that is less than 2 or greater than -2 I've got that totally backwards. Any z-score that is greater than 2 or less than -2 would be a rare event. In your classroom, you will probably do many simulations in gathering your data. One problem that is probably would be of interest to the students. Well, first of all, a simulation is an experiment that closely resembles the given situation. And a cute example they give you in your book is, you know how students are very interested in getting the prizes that are in cereal. So if they have superhero cards in cereal and there are 7 different ones, how many boxes of cereal are you going to have to buy in order to get all 7 superheroes? So the simulation that you might do would be to take chips. You would need 7 chips, maybe of different colors, and put them in a hat, or maybe write on the chips the numbers 1 through 7. And then you would shake them up and you would draw out that number. And you would keep, so I shake these up, I draw out the number 4. I put 4 back in the hat, and I shake it up and I draw out something else. You put 6 back in the hat, shake it up, and you continue doing this until you eventually get all 7. So if I repeat 4 and 6, I write that down because that was an event. And so eventually you will end up getting all 7 numbers, and then you count how many times you had to do that simulation for you to get all 7 cards. Alright, you should look at the odd-numbered problems on section 7.3 and check your answers in the back of the book. Also, you have a chapter review and a chapter test. I would look over those before I attempt the exam 7.